So in the previous examples, the reasons in the two-column proof have been given for verifying the trig identity, and we would fill in the steps as we go. Okay, in this example, we're going to do the reverse. The steps are given here, and we want to figure out the reasons why those steps were able to be done. And you want to always look at what came from the line above in order to decide what the reason is for the line that you're on. So the first step is always based on given information. And when we look up at the given information, we see that the person chose the more complicated side to use in line 1. Okay, then to get from line 1 to line 2, we're going to ask ourselves what's different. So what's in the parentheses, that quantity is still the same from line 1 to line 2. Nothing changed with this secant to the 6x minus secant to the 4th x. That's stayed exactly the same. And similarly, this tangent has stayed the same. So what changed from line 1 to line 2 is that this sine of x times secant of x, that product was replaced with tangent of x. And if we look at our identities hexagon, we just want to check and make sure that that's allowed, that that's really in fact a product identity. So tangent, sine, cosine, then the reciprocals, secant, cosecant, cotangent. A 1 always goes in the middle. And remember that the product identities, they form a hinge. So the vertex to the right and left of any other vertex, that product forms the middle. So I'm looking at sine and secant. So here's my sine, here's my secant, and right in the middle of those two, sine and secant, is tangent. And so that's correct. Sine times secant equals tangent. That's a product identity. So that'll be our reason for line 2, product identity. Okay, then as we look down from line 2 to line 3, this quantity secant to the 6x minus secant to the 4th x, that's still the same. Nothing's changed there. But this tangent of x times tangent of x, that has been combined to give us a tangent squared of x. Okay, and that is just multiplication. Okay, so now we're on step number 4, and when we compare now from lines 3 to 4, we can see that this tangent squared x did not change, right? That stayed the same. But this quantity that's been in parentheses this whole time, secant to the 6x minus secant to the 4th x, that has been modified. And you can see as we go from one line to the next that it's this secant to the 4th of x that's been factored out of these two terms in the binomial as a GCF. So this is factoring out the GCF, and that GCF, the greatest common factor in this case, is secant to the 4th x. When we factor that out of the binomial, we're left with a secant squared x minus 1 in the parentheses. Okay, now as we look from line 4 to line 5, here's that tangent squared x again from the previous line. Here's the secant to the 4th x, also from the previous line, so that didn't change. What's different is this quantity here in parentheses, this secant squared x minus 1, that has been replaced with a tangent squared x, and that would be a Pythagorean identity. So let's just look over at our hexagon, verify that that's correct. So remember, the Pythagorean identities make these triangles. Sine squared x plus cosine squared x equals 1. That's the top triangle. Then we have 1 plus cotangent squared x equals cosecant squared x. That's our second triangle. And then the third one is that tangent squared x plus 1 equals secant squared x. And that's the third triangle in the identities hexagon. So if we notice, we've got tangents and secants here in our problem. So that's going to be the Pythagorean identity we want to focus on. Tangent squared x plus 1 is equal to secant squared x. So if we wanted to make that Pythagorean identity match what we see in line 4, we would subtract 1 from both sides, and then tangent squared x is equal to secant squared x minus 1. And that's what got replaced from line 4 to line 5. So the reason for line 5 we would list in the proof as the Pythagorean identity. And you can abbreviate identity if you don't have room to write it all out. Okay, so in the last line, let's see, we're at 1, 2, 3, 4, 5, 6. So line 6, to get that reason, we want to look back at line 5 and see what's different. So the secant to the 4th x has stayed the same, nothing changed there. But these two tangent squared x terms from line 5, they have been condensed now into the tangent 4th of x, and that again would be multiply. A squared times a squared is a 4th power. And then what we ended with matches what we were trying to prove at the beginning, and so that identity has been verified, and we put a check mark to say it's done. Okay, so you'll go ahead and try the checkpoint problem, and then we'll come back in the next video and see how you did on that one.